In this presentations, we are going to discuss about the operating system design and implementations. The contents are OS design goal, OS implementation, kernel structure. So in this design goal, the designs and implementations of OS not solvable, but some approaches have proven successful. The internal structure of different operating systems can vary widely. Start the designs by defining the goals and specifications. So the design goals are needed for both user and the systems. The user goals are the operating system should be convenient to use, easy to learn, reliable, safe and fast. In the system goals are the operating system should be easy to design, implement and maintain, as well as flexible, reliable, error-free and efficient. In the implementation, the existing OSs are designed in assembly language like Arco, PL, like that. So nowadays it is designed and implemented in C and C++. That's a high level languages. If it is designed and implemented in the high level languages, it is easier to port to the other hardware. Then the operating system structure. The general purpose OS is very large program, so it has various structures. The first one is simple structure, more complex, then layer structure, microkernel, models and hybrid. In the simple structures is an example MS-DOS. So the MS-DOS written to provide the most functionality in the least space, so not divided into models. Although the MS-DOS has some structure, its interface and levels of functionality are not well separated. And the second approach is non-simple structure, that's an Unix. The Unix is limited by the hardware functionality. The original Unix operating systems had limited structuring. The Unix OS consists of two separable parts. The first one is system program, second one is kernel, where it consists of everything below the system call interface and above the physical hardware. So provides the file system, CPU scheduling, memory management and other operating system functions, and also have a large number of functions for one level. So in this traditional structure, so for the Unix OS, the kernels is main part to execute the system call. It also maintains the signal terminals and the file system swapping management and the CPU scheduling, then the device controller for the disk and tapes, the memory controllers for the physical memory and the terminal controller processing. The next approach is layered approach. The operating systems is divided into number of layers, each built on top of load layers. The bottom layer is numbered as 0 is the hardware. The highest layer is numbered as N is the user interface. With the modularity, layers are selected such that each uses functions and services of only lower level layers. The main advantages of the layered approach is simplify the constructions and the debugging. The next approach is microkernel system structure. So here the moves too much from the kernel into user interface. Here match examples of microkernels, that's an Mac OS X kernels, partly based on match. The communications task plays between the user models using message passing, so it is a more benefitable. So using the message passing, the kernels and the OS to be communicated, so it is an easier to extend the process and scheduling to be easier, and it is an more secure compared to the existing. So that internal structure, so the application program, file system, then the device drive, everything easily handled by the micro kernel with the process of the managed development, that's in memory management, CPU scheduling, inter-process communications, that are everything to be interfaced to the hardware. Then the fifth approach is models. Many modern operating systems implement loadable kernel model. So here uses object-oriented approaches. Each core components is separated. So each task to the others over known interfaces. So each is loaded as needed with the kernel. So overall it is a simple and very easy to extend the OS. So it is a more flexible. So the examples of for this approach is Solaris modular approach. So here the everything process, that's in scheduling, file systems, loadable executions, everything to be handled by the core Solaris kernels. Then the next approach is hybrid systems. So most modern computer operating systems are actually not one pure model, it is a hybrid. Okay, so the hybrid combines multiple approaches to address performance, security, usability needs. So the Linux and Solaris kernels in the kernel address space is so monolithic plus modular for dynamic loading of the functionality. So the Windows mostly monolithic plus microkernel for different subsystem personality. So when the hybrid is also formed by the layered or the kernel. So that kind of systems to give efficient compared to the existing. It is more advantage and have more functionality with both the systems. Then the kernel structure. So in this kernel is used for the processing. Here the data are stored in the following format. Here many similar to standard programming data structures, that are singly linked list, doubly linked list, circular linked list. In the singly linked list, each data are communicated. So the first data is connected with the second data by the address of the second data. So that is in single linked list. In the doubly linked list, each data has two address pointer 1 and pointer 2. In the second pointer has the address of the next upcoming data address. The first pointer is null for the beginning of the linked list. And thus afterwards the data, each data has a two pointer. The first pointer has the previous data information and the next pointer has the next upcoming data informations. In the circular linked list, each data has two pointers. Okay, so here the next data information is available in the pointer 2. The first data pointer is the last data address is stored. Then the kernel data structures is also represented in the binary search tree. So actually binary search tree concept is the left child values to be low compared to the right child. So in that combinations the data are stored in the kernels also. Then another data structure is hash functions is also used. So using the hash value the data are stored in the memory. Okay, thank you.